Hello and welcome to Learn Yourself. Today we are going to learn about pH value of medium. This topic is under ICSE Standard 10 syllabus from the chapter 3 Acid, Base and Salts. So first of all, what is a pH? When any solution we do have, then we will check whether it is a neutral solution or it is acidic or it is a base. So first, you all know that a handy one is a litmus paper. When there are two types of litmus paper. You must have performed an experiment in your laboratory. There are two types of litmus paper. One is red, another one is blue. When blue turns red, we will see that the solution is acidic. When red turns blue, that means the solution is basic. And on both the litmus paper there is no change, then we can say that the solution is neutral. Now what is the meaning of that? This is our pH scale. In this, from number 1 to 14 I have marked, and this range from number 1 to 7 we term, if the solution has a pH in between 1 to 7, we term that solution is an acidic solution. If pH is above 7 till 14, then we termed as the solution is basic. Always remember, when any gas is there, for example hydrogen chloride gas, if you will put a litmus paper in a gas, you will not be able to see any color change. It has to be in aqueous solution. Why? Because an hydrogen chloride gas will not have any H plus ion, a free H plus ion. When it dissociates in aqueous solution, it will give us H plus and Cl minus. This H plus ion is responsible for color change. Any indicator you will take. Similarly in the base, NaOH, if dry palette of NaOH you will take and you will put it on the litmus paper, it will not show any color change. When you will dissolve this in an aqueous solution or in a water medium, then only it will dissociate into Na plus and OH minus, and this OH minus ions are responsible for the color change from red to blue. So always remember that acid and base, when they are dissociate, this H plus ion and this OH minus ion are responsible for a color change. So here, what is a pH? Basically, pH is a product of water. How? Ionic product of water. What is an ionic product of water? When it is H2O, what we will get from this? H plus and OH minus. So these two are the ionic product of water. So H plus and OH minus. This, in the definition we will see that what is a pH? The negative logarithm. It is a negative logarithm of the hydrogen ion, concentration expressed in mole per liter. So here 10 minus 7 into 10 minus 7. The concentration of H plus is 10 minus 7 and the concentration of OH minus is 10 minus 7. So collectively it will be 10 raised to minus 14. So here in pH we will always count a concentration of H plus ion. We will not count a concentration of OH minus ion. So if it is a basic solution, the concentration of H plus ion will be less. H plus will be there, but the concentration will be very, very less. Why? When you are dissolving NaOH into the water, what will happen? NaOH plus water. What all types of ions you will get? Na plus, OH minus from this. Again, a dissociation product of water. You will get H plus plus OH minus. Here if you will see, the concentration of OH minus has been doubled compared to H plus. So this H plus ion concentration will be very less in basic solution. So if we will check the pH range, you will get pH almost in this range, and NaOH is very strong alkali, so you will get somewhere after 10. The pH of this solution will be basic. Why? Because the OH minus concentration will be increased and H plus ion concentration will be very less. So in basic solution also H plus ion will be there, but the concentration is very less. That's why that pH has been shifted from neutral to basic. Now what are the types of indicators we are using? So these are the types of indicators we are using. First is litmus. Litmus solution also will be there, and litmus papers will be also there. The blue and red. Then methyl orange and phenolphthalein. We will discuss more about the indicators. There are two types of indicators, common indicators and universal indicators. We will discuss the difference between both two in our next segment. Indicators. Why we are using indicators? To check whether the solution is alkaline or basic. And another type of indicators which are known as universal indicator. They will show you the exact pH for the solution. Yes, we do know that this is an acidic solution, but if we want to know that whether it is a strong acid or it is a weak acid, so whether it lies in between 1 to 3 pH range or it will lie in between 5 to 7 or 5 to 6. If it is 5 to 6, it is weak acid. As it goes near to 7, a neutral pH, the strength of acid is decreasing, and as it goes from 7 to 1, the strength of acid increased. So if we want to see that whether the strength is more or less, similarly for the base, if we want to know that strength of base is more or less, whether it is a strong alkali or weak alkali, that we will get to know from universal indicator. So this is a main basic difference between common indicators and universal indicators. Common indicators will only show a color change and only show that whether it is acidic or basic. Universal indicator will perfectly show you the pH of the solution. So from pH you will obviously you will get to know that whether this is acid or base, but the perfect pH will show you the strength of acid or base. So here, these are the examples. What are the common indicators? Litmus, methyl orange and phenolphthalein. Here organic dyes we are using for universal indicators. So it indicates solution is alkaline or acidic. This is a limitation for a common indicators, where it indicates a strength of pH. For example, again, here it is a 7, here it is a 1 and here it is 14. This is our pH range. If it goes towards 1, then it is strong acid. If it goes towards 7, it becomes weak and weaker. As it goes far from 7, it is strong base, and it comes near to 7, it is weak base. So once it will show whether it is here or here, you can say that this is a weak acid, this is a strong acid. Here you can say it is a weak base, it is a strong base. So can't use to check pH. This is a limitation of common indicators. We cannot check pH through this common indicators. Utilized to see strength of acid and base. Also, we know that this is an acid, this is an hydrochloric acid, but we want to know whether this is a concentrated hydrochloric acid or diluted hydrochloric acid. Then we can also use this indicator. It will show you a pH mark, and from that you can decide whether this is a strong acid or diluted one. Can't differentiate between pH value. It will not show any kind of pH change, or it will not show whether it is a strong or weak. And here if you will see that this is one type of organic dye, it shows a 3 type of color change in between 7 to 14 pH range: blue, indigo and violet. So if it transits from blue to indigo, you can say that this is a weak alkali. If it's indigo to violet, you can say it is a strong alkali. So this is a basic difference between common and universal indicator. What are the common indicators? Litmus, methyl orange, phenolphthalein. Whereas in universal indicators, we do use organic dyes.